So yesterday I had taught you that there were two different ways that you could solve this. Now, because some people had some problems with the fraction with borrowing. So I had showed you the making it an improper fraction technique or strategy. But if you see how large this fraction is right here, you can see where this would be a problem. So I'm not going to tell you which way you have to do. You do whatever works for you. But if you struggle with getting your multiplication right, doing the improper fraction strategy could be a problem. So if you're kind of going, what are you talking about? I forgot, because I didn't post the video yesterday because it was so short. And I didn't give you the homework, so I didn't really see the point. But the original way was 17 2/3 minus 5 5/6. Well, I know that I cannot subtract these because I do not have a common denominator. I can't do it. I need to find the common denominator. The best thing to do is find the least common denominator. And sure, 18 works because I can just take those and I know I can multiply them together. However, if I do my little chart off to the side, three, 6, 9, 12, 6, 12, 18, 24, then I see that they have 6 in common, they have 12 in common, and they would actually have 18 in common if I kept going. So they have quite a few things in common, but it would be a good idea to find the least common denominator. So I could do 6 because it's easier. 3 to get to 6, 2 times. 2 times 2 is 4. 6 to get to 6. Do I have to do anything?
No.
No. I leave this one alone. Because 6 to get to 6, 1 time. So I just leave that alone. 4 minus 5, I can't do it. And I know what some people do is they're like, oh, I can't subtract it this way, so I'm going to take my fractions, I'm going to switch them around. I can't do 5 minus 17. You do not switch your things. I've seen so many people do weird stuff. This one is supposed to be in the front. This one has to be in the front. It stays there. So I have to borrow from here. The 17 becomes 16. I only borrow one number. So in here, I get 6, 6. I borrow one whole, it becomes a fraction. Plus the 4, 6, that's already there. So 6 plus 4, 10. So 16 and 10, 6. So, and then 5, 5, 6. So now I can subtract this. 16 minus 5 is 11. 10 minus 5, 5. 11 and 5, 6. So I know that for some people this is just the easier strategy, but I know that this is the part right here that messes them up. They don't like it. So a couple people yesterday, I showed them Well, you can always take this and just do taking it from a mixed fraction and make it an improper fraction. But it gets very ugly very quickly. So I'm going to write it over here because I don't have room and I want you to be able to see it. I can take 17 and 2/3 minus 5 and 5/6. I don't care which strategy you use. Just get it right. 17 times 3, that's 21, that's 51, plus 2, 53. So this becomes 53 thirds. So I make it an improper fraction. To subtract 6 times 5 plus 5, 35 6. I still can't do it because I still don't have a common denominator. Still have to give it a common denominator of 6. So now I have to multiply 53 times 2. 106. Not pretty. I know. Then it's still improper. You have to make it mixed. So, but some people get this better. And some people aren't writing anything at all, which is very disappointing. So then I have to make this improper. It is improper. Make this mixed. 1, 0. How did I get that? What did I do? I don't know. I did something. Borrowed. I borrowed and I shouldn't have borrowed. I get so borrow happy sometimes. I did like children. I'm a goober. 106. See, sometimes I make 71. 6 and 2, 70. Good grief. 11, 1. 11 and 5, 6. There we go. Okay. So it really doesn't save you any work to do it the other way when you've got these huge fractions. But you have to do it either this way or this way because you're going to run into these types of problems. Yes, ma'am.
I thought that you would have to take away, like, subtract 17 and 5.
Well, I would have to subtract 7. Oh, you mean like way up here?
Yeah, all of it.
Well, I don't at the very beginning because I might have to borrow from it. And I mean, I probably could have where I would have the 12 up here and then borrow from it, and then I would have ended up with 11 anyway. Either way. Yes. Because when I do this, when I do improper to mix, I divide and subtract. So when I'm going this way, I do the opposite. I multiply and add. So it's an opposite operation. Does that make sense? Are you sure you're not just nodding to make me happy? Okay. Sometimes y'all go, oh, and you don't get it. So it's just an opposite because I'm doing opposite of what I'm doing here. So this is dividing and subtracting. So then this is multiplying and adding. It's just the opposite of what I did before. Okay. Personally, I prefer this only because I figured it out. Last year I was like, huh? But once I figured it out, I was like, oh, okay, borrow one, turn it into a fraction. All right, I got it. This has more room for error because your fractions get so big. You see, I screwed it up just because I was subtracting and borrowed when I didn't need to. Duh. So you pick what strategy works for you, but you have to do something. I've got people who are still, when they're making their equivalent fractions up here, aren't changing the numerators. Or are telling me that this would be, I don't even know, telling me that that might be 3/3 and then changing it into 1. So they're not changing anything. Like, I haven't been teaching fractions for over a week. So, you know, you need to be writing something down because I'm about to erase all this. When I'm writing, you should be writing because now you're kind of hijacking the class while I'm having to wait. Because I need to do the letter H and I can't. So if you have already written something down, thank you. And I would like you to try to do letter H. 18 1/3 minus 3 3/8. I would like you to do H. 18 1/3 minus 3 3/8. What he is saying is if you do 7 1/4 and you subtract 3 3 3/4, he says that you should get 4 2/4, which would simplify, which is actually equal to 4 1/2. Is he correct? And it says draw a number line, which I really don't like using number lines to do computation. I like just doing computation. So what I want you to do is solve this and see if it is actually equal to 4 2/4, which would be equal to 4 1/2. I haven't even solved it yet. So, is it equal to 4 2/4? 7 becomes a 6. 4/4 plus 1/4 minus 3 3/4. 6 5/4 minus 3 3/4 equals 3 2/4, which can be simplified. 3 1/2. So he was not right. He was incorrect. Mr. Neville Ice Guy mixed up 12 3/5 gallons of chili for a party. Chili. That's a lot of chili. If 7 3/4 gallons of chili was mild and the rest was extra spicy. So if you think about this as a bar model, the total, all of the chili, was 12 3/5 gallons. Some of it was 7 3/4, was mild. The extra spicy, we don't know. If we're missing a part, if we're missing an add-in, what are you supposed to do? Subtract. When you're missing the total number, that's when you are supposed to add. When you're missing one of your little bars right here, that's when you are supposed to subtract. So you have your total minus your parts. 7 3/4. You have to figure out what was this missing piece. Common denominator at 20. 5 to get to 20. 4. 3 times 4, 12. 4 to get to 20. 5. 3 times 5, 15. So there's 12, there's 7. 12 minus 15 cannot do. So the 12 will become an 11. 20, 20th plus 12, 20th. Sitting's not hard, Jonathan. So it's 11, 32 over 20, oops, minus 7, 15 over 20, with 4, 17, 20. Jasmine decided to spend 6½ hours studying over the weekend. So, let's see, the weekend. So we have 6½ hours studying over the weekend. She spent 1 1/4 hours studying on Friday. So, 1 1/4 hours studying on Friday evening. 2 2 hours on Saturday. How much longer? Oh, this is a multi-step problem. How much longer does she need to spend studying on Sunday in order to reach her goal? How much longer does she need to spend studying on Sunday in order to reach her goal? So basically, what is the time that we need here? However, it is something that you need to work 2 steps in order to solve this problem. It is a 2-step problem. The first thing would be to do Friday and Saturday. So you would, you can take this and subtract that, and then take the total and then subtract that, but why? So I would not take all the numbers and add them up. And you can't, I would not do like this because that never ends well. I just made up a number. This never ends well. Because when you're doing fractions, it never ends well. So what you should do is take these, add them together, take that total, subtract it from here. So Friday and Saturday, 1 1/4 plus 2 2/3. Common denominator, 12. If I'm writing this down and you had no idea what to do, what should you be doing? Writing it down, because when you get your homework tonight, it's highly likely there will be a problem similar to this. Don't scowl at me. We've been doing this enough times. So 12, 12. 4 to get to 12 is 3. 1 times 3 is 3. 3 to get to 12 is 4. 2 times 4 is 8. So then you get 1 plus 2 is 3. 3 plus 8 is 11. So these 2 days, Friday and Saturday, she did 3 11/12 hours. But you're not done. They want to know how many should she study on Sunday to reach her goal of 6½ hours. So you would have to do her goal of 6.5 hours minus the 3 and 11/12 hours that she already did. Now, yeah, you can do a common denominator of 24, but why? 2 can go into 12. So 12, 2 to get to 12, 6. 1 times 6, 6. This is already the common denominator. You can't subtract 6 minus 11. 6 becomes a 5, 12 twelfths plus 6 twelfths. This is 18 twelfths. Two and 7/12 hours is what she needs to do on Sunday.
I did that.